Okay, a couple of things I should have changed. As I was changing the program, I put everything back to 32-bit, and the motor count is back to unsigned int, and yeah, overall, wherever I removed the 32, I kept it there. So essentially, what the error is referring to is that the pointer of void is used in arithmetic, um, and then when it's referenced, the motor count read-based offset is used along with the uh, void again, and it's depositing its value into the motor count read map, which is 32-bit at this point. However, we are not using the 32-bit, so we are going to first of all reduce this to the 8 bits throughout, all over basically. And our lightweight as well. We are going to make sure that this is also the the mapping basically is also. Let me make sure that I'm referring to the right one. And the lightweight bridge map is also going to be unsigned int 8. And throughout, we will make sure that wherever we are using 32, we bring it down to 8. And yeah, 8 bits. I don't see it anywhere else. Let's see what, if it complains, we'll find out. And this time it's fine. Okay. Let me see. So before I change this, I think our motor output was the next one over. So I'm going to hook up our motor connection. Let me see, where's my, oh yeah, it is alive. Alive. Sometimes the video just quit. The video from the camera output just quits. So I have to make sure that it doesn't happen. And the ground is connected. Okay, right now, as you can see, the motor is connected to the FPGA output. Now we will switch to the one over, and this is supposed to be our HPS output. Not sure if it's pulling out anything right now. Not sure if it's responding. Okay, nonetheless, we'll move to the next step. And what I want to do is make the connection over the terminal. It's easier for me to decipher exactly the state of the code. So what I'm going to do is basically run it. Let's overlap to our console session. I will basically run it over this terminal window, and so if something freezes, we can safely disconnect. Okay, so and this should be in distribution. Debug GNU, and this is our code. All right, let's see what it does. Oh, yeah, it's expecting an argument. If there's no we can remove this piece. I don't need this. We are not using the argument. Back to our code. And because it's not putting out any output, we don't know where it's at. So we want to put out a output. And at the beginning, there is some sort of a, oh, there's a clock skew detected. Let me make sure that that's resolved. There's a way to set the time. We can I've done it before using this one. It's already saved. No. Down here, sample output, there's a, it's not the date. It's a very simple command, just time, and then I think there's a date format I have to do. Let's see. If I do time, oh, it is date. Okay, yeah, no, never mind. I am thinking of another. Okay, this is how it should be. I'll take that. Ah, definitely. It's slow in response. Okay. Date dot s, and I'll say equals. Does it say equal? No. Today is 13th. And this is 14:45. Okay. Now that error should disappear. Yep. There goes. Oh, hold on. I don't want to run it right now. Just compile. Just compile, please. Yeah, there you go. Error disappeared. No more errors. And my count 1, 2, 4. Oh, it's counting twice. 6. It's counting in step 2. I don't want to do that. Yeah, it's counting in steps, 2 steps at a time. Okay. All right, no problem. As long as it's counting up. And you know what? I can read from the memory as well. Make sure that it's writing to the memory. Take the value. Mem value. Unsigned integer output. Two. Okay. It is writing. So our motor count is writing. Question is our FPGA. Does our FPGA is reading? I do not see my motor move. So let me see what I can do here. Let's see. We can open this. I want to make sure that my pin is referenced correctly. Probably was this pin. Let's try now. No. Should move just like that. Okay. So my pin 2, I want to see where it's mapped to. So pin 2 is AH14. AH14 AH14, our pin map is somewhere up here. Nope, it's down here. Right here. Okay, AH14. Did I do AH14? Why did I do AH14? Pin 6. Why did I do pin 6? EH3 is pin 9, yes. And then pin 10. Let me see. This is 10 should be my ground. 85. No, that's not correct. Hold on. GPIO 0. So okay, this is a good reference. Let me pull this up here. Okay, now GPIO 0. GPIO 0 is the one next to the power connector, which is in our case is right here. And in GPIO 0, we are connected to 12 for the ground. The next pin over, the one that's working, is pin 10, AH3 right there. And AH14 should have been pin 8. So the one over. So 12, 10, and 8. This should have been the 8. You have 2, 4, 6, 8. 2, 4, 6, 8. I'm connected to the right one. Not sure what is going on. There is no change in the output. So definitely our code is not picking up the pin output, or maybe we are not cycling it right. Let's see what our pin output looks like. So our LED 2 out, LED pin 2, HPS pulse out. FPGA clock 150, it's at even faster hertz, so it doesn't matter what we are doing. Okay, so I need to slow it down. Initially, the first LED example, as you can see, there's an error there. First, in the first LED example I used the 762 hertz, which is the basically slower version or slower output of the 50 megahertz clock. And with that slower output, using the LED, we then slow it down further. Not sorry, I take it back. Not using the LED, using the switch, we slow it down further. So slower pulse comes in, then we count, and then we count until the count is equal to the switch. So we use the same process, or and I should say procedure, and we copy that over, but we did not use the slower pulse. So essentially what's going on, it is pulsing it, but it's pulsing it still very, very fast. So that's why the light, the very first light, is hung on the on state. It's just too fast. But the question here is why the output does not change for us. It should change. Even though it's pulsing faster, the motor should give me some kind of a reaction. I'm not getting anything. So either my current driver here does not detect a pulse faster in the 50 megahertz range, or the pin output is not giving us the correct output. So we pull out the multimeter. Okay, let's see. And I have a bad multimeter. Looks like it is working. It looks like it's working. What I want to do is I want to see. Oh, there's an output. Okay. There is an output. Let's see if I change it to a different one. No, that's not right. That's not right. Hold on. I need a good contact point. No, it's the same. Same response. Let me get my wires. Okay, we have a ground and we have a output source. Let's touch the leads. Now this is the one that's controlled by the FPGA. Hertz. Okay, so 11 hertz is the output. Let's see, what do we get here? $833 kilohertz. Okay, let's try this. We run our code and it should change every 5 seconds. There you go, 2 and 1.7. Oh, it is changing. Okay, so that's good. That's good news. Don't shake, don't shake. Okay, 10, 961 kilohertz. So okay, 14, 833, and it's going to stay on 833. So if we go back, maybe I should get clips for this. I'll be back in a moment. Hold on. So I'm back. I have alligator clips, and now I'm going to use these clips to hang on these connection points. Let's change our pokeaux, what you call, anyways. So 833K, the last it left on that. Let's see, at 0 it's 12 megahertz, and 2 is 4 megahertz, 4.1. 4 is 2.4 megahertz, and it's jumping 2. I wanted to just go one at a time. Something isn't right in my program. I clearly just asked it to increment once. Did I do? Oh, yeah. Okay. My mistake. Sorry, guys. Sorry, everybody. Sorry, folks. Let's recompile. I'll recompile it again. All right, let's recompile. Now it's going to go through the whole 15 bits one at a time. Yeah, that's better. 6 megahertz. 4 megahertz. Now this is correct. And 3.1 megahertz. Okay, so the output is received and the FPGA is counting as it is programmed to do. The frequency, although, is, however, it is high. So let's change that. And this time what I will do is just stop the video and compile and copy the RBF file to the SD card and come back to this again. So just give me a moment and we'll come back to this quickly. Okay, folks, so instead of going through the whole process in the video, I recompiled, basically changed the source from 50 megahertz to 762 hertz, just like the FPGA driven process. and it should give us the correct output. I already compiled this and I converted the file into RBF already, and now I want to copy this over to my SD card. Now here I want to use a Linux Linux copy method over SSH, which is this SCP. Oh, first I have to get to this location. This is, let me get to that project folder, DE10-nano. This is the project. And the RBF file is out in, no, it should be in the output files. Let me see, it does say it's there. Let's do ls. 13th, okay, it's there. Yeah, it's there. Okay. Now I want to SCP this file over to my DE10-nano, which is 40.10. And I want to send it to, let's see, where do I want to send this to? To my mount location. This is in the root directory, mnt, and this is copied over. Output RBF. Let's make sure this is our file. Let me see, toolbar path. Detail list, I like this way. And 13th, there you go. I don't want this. Rename. Remove, yes please. And rename this guy as our primary program. And now we will reboot. Connection is closed. Rebooting. Ah, it's working. So if you notice, where's my pencil? The first light, which is connected to our HPS code, is now blinking. Similar rate as our FPGA. If I change it back, you'll see the two sync. So they're blinking with the same 762 hertz. And let's get to our code. Come on. Okay. And here the 10 should change every 5 seconds. The motor, oh, there it is. Okay, there it is. So now HP has the control. Oh, my video is still zoomed in. But probably you can hear the clicks. They're changing every time. And then let's see our hertz. The frequency is going to also change. 2.9 hertz. So every 5 seconds it's going to just increment to the next one and the next one and the next one, and the frequency is going to change every time. This should flip the frequency. What's going on here? Yeah, there it goes. Okay, now this demonstrates the HPS writing to the FPGA, and then FPGA taking that and then altering the stepper motor output. Okay, so basically we are controlling the stepper motor through the HPS. So now, as you can see, we can write a program in the C++ and basically control our FPGA through that. And obviously for the UART connection, as I intended in the first part or the second part, one or the other, I intended this port to be the one for my UART connection. So eventually I have to disable the console output from this UART port, and what I will do is open that port from the C++ program and read that port and then receive the traffic, just like I have the Arduino driver program to do. It receives commands over the UART connection, and it then performs the actions based on the commands. Yeah, that's basically exactly what I want to do here. We can do another part for write portion, but I think what I should do, because I think this will be a very long video. When I compile, then exactly I will find out exactly what I can remove, what I can keep, and what I will do is make the read portion or connect the read portion with another part, so we can clearly see the progress, or quickly see the progress, instead of one giant video that probably will bore you. So I'm just hoping that with separating the read portion and the write portion, it may help you understand this progress and understand how these two different pieces work together right now. So I'll stop here and wait for my next part, and in the next part I will give you a good progress of the I will share a good progress with in the next part I will share a good progress of read and write, and also the motor control, as some advanced motor control that will be built into the HPS. So you'll see the a good transition from a simple basic program to a much more complex level program. So thank you if you stayed with me until until the end of this video. Thank you very much. Please do subscribe. Please do give me some comments. Any any input from you is definitely going to help me orient these videos to your uh, to your uh, to your view, uh, to your to your perspective, so I can adjust and give you a better video the next time. So stay tuned to my channel, and thank you for your thank you for viewing my videos in this project. So throughout the video, I don't think this recorded very well, so I'm recording it one more time. So this is basically the output. I noticed that my video was out and I recorded the full length. So essentially the motor output worked, and let me rerun this one more time. So now HPS is writing 1, 2, 3, 4, 5 all the way up to 15, and as it writes these numbers, FPGA reads that from the lightweight memory. It then put this through its delay within its procedure, and it's basically this procedure that it's going through. It's taking the HPS counter and then it's comparing it against its own counter, and if the two match, it does the pulse, and if they don't match, it continues the counter. So basically figuring out how slow or fast I intend, or the HPS intend for the motor to run. So this is the baseline project, and this gives us an exact idea of how we can control the motor through the HPS. So through this baseline project, now I'm going to scale it out into a full UART controlled project. Essentially what I'll do is use this UART connection and write up a program in C++ in the HPS basically to read the UART, and the UART will define the exact speed through commands, to different set of commands, which will be similar to, or I'll keep it exactly similar or exactly the same as the Arduino commands. So from the client perspective of this motor, nothing will change, and through commands, basically I will control the speed of the motor, and I will also define other parameters that as I get to that point where I can clearly control all the aspects as I do from the Arduino driver. I'll try to do the same in this one, and when I get ready, when I'm ready, I'll make another part, next part to this upgrade project. I'll create the next part of this project. So until then, please stay tuned to my channel. Please subscribe. Let me know what you want to see additionally in the next video. Let me know what I need to improve in. Let me know if something that did not make sense to you. Do let me know. Put that in comments. Thank you for your support, and we will meet in the next video. Thank you very much. Bye bye.